Hey students, we're going to work on taking a table and finding the equation from that table, from solutions. Now each one of these things represents a coordinate. So like there's a graph somewhere that has the point 0, 9, 1, 8, 2, 7, 3, 6. Those are like little dots that are on the graph. And we're going to use that, knowing that those are dots or solutions, to find the equation of the line. Now remember, our equation needs two things. We need the y-intercept and we need the slope. Okay, and I'm going to find those things. So my y-intercept is where it starts on the graph. And a better, more accurate representation is where my line or my solution goes across the y-axis. Okay, so I'm looking for that point right there, where that point is. And I can always find that because that point right there might be at 0, maybe 3, and my y-intercept is going to be 3. So I'm looking for a spot where x equals 0. So in my table, wherever x equals 0, my y-intercept is going to be whatever y is. So when I look at this table here, I can see that when x equals 0, y equals 9, that indeed is my y-intercept, which is the first part of what I need for my equation. So my equation right now is y equals something x, and my y-intercept I already know is plus 9. So the second thing I'm looking for is my slope, which is going to become my coefficient. So I'm looking at my slope here. I can see that by the change, okay? And that's going to show up as my change in y. For this one. The reason why it's just a change in the y, because when I look at the x, it's going down, it's changing 1 each time. So 0, 1, 2, 3. It's changing 1 each time. So when it does that, I can go ahead and just look at the change for each one. So it goes 9 to 8, which is minus 1. It goes from 8 to 7, which is minus 1. And it goes 7 to 6, which is minus 1. And I can see my slope. It's changing -1 each time, which is my slope. And we'll practice this out a little bit. I'll come back to this because I'm going to show you that ratio of rise to run. And so we'll come back to this graph and show you that you can even see it here. Okay, here's another table. I'm going to go ahead, again, I'm looking for the y-intercept, and I'm looking for the slope. Once I have those two things, I indeed have my equation. So my y-intercept is where x equals 0, and x is 0, and y is 0. So my y-intercept is at 0. This goes to the origin, O-R-I-G-I-N. My slope, whoa, okay, so I noticed that my slope from 0 to 3, or from 0 to 6 is 6, and from 6 to 9 is 3. So it's not consistent, but if I notice over here, it's missing the 1. It doesn't go 0, 1, 2, 3, it goes 0, 2, 3. So if I add the 1 in here, I can see that it's going to go 1 to 3 to 6 to 9. So if I rework that, I can see that it goes 0 to 3, which is 3, 3 to 6, which is 3, 6 to 9, which is 3. My slope is 3. So my equation is going to be y equals 3x, and then my y-intercept is really plus 0, but I'm not going to include that in there. So it ends up being y equals 3x. Again, I'll come back to this one and to try the ratio of rise to run, because I want you to see how that plays out in that one. I've got this one right here. So let's take a look. I'm going to be trying to find what the y-intercept and the slope. Okay, y-intercept is going to be where x is 0, so it's right there. My y-intercept is 1. And my slope is going to be, it goes, okay, 0, 1, 2, so it changes, okay, this one changes by 4, and this changes by 4, so my slope is 4. I know my equation now. Y equals 1x, and my y-intercept is plus 4. I've got all my pieces here. All right, this guy, a little bit funky, because look here, I'm still looking for the y-intercept, and I'm still looking for slope. Oh, that looks like it says glope. Slope. That doesn't look like slope either, but I'm going to move on. My y-intercept is going to be at 0. And you know what? Sometimes your tables doesn't show 0. So it just happens to have it here, and sometimes you have to calculate it, but on all these, you've calculated it, or you've just looked at it and found it. It's going to be 9. Now the slope is a little bit different. Notice it goes 0, 2, then 4. It doesn't go up by ones. So I'm going to use what I know about my ratio of rise to run. Now normally we've done that on the graph. And I've looked at a graph, and I've looked at a line. I've tried to figure out, okay, well, if I find a point on the line and I find a point on the line, I'm trying to find how much does it rise and how much does it run, and I find those numbers. Well, you can do that here. I mean, rising is something that happens on the y, and so we can see that it's the y, and running is something that happens on the x. So it's my change in y over change in x. So let's go ahead and build this ratio out, okay? So my slope is going to be rise, so I'm going to look at my rise and I'm going to look at my run. So let's do that. So I'm going to look at first my rise. How much does it rise? And my rise is my y. And so I'm going to look at my y. So it rises. So from 9 to 5 is minus 4. From 5 to 1 is minus 4. So this is rising consistently by negative 4. Now I'm going to go ahead and look at the run. Now the run is my x. So my run is my x. My run is my x. So I'm going to look at my x here, and I'm just seeing if it's consistent. So 0 to 2 is 2. 2 to 4 is 2. It is consistent. So this runs 2 each time. Negative 4 divided by 2 is negative 2. So my slope for this is indeed negative 2. And once I have my y-intercept and my slope, I know that I have my equation. So y equals negative 2x plus my y-intercept of 9. Okay, now notice that rise to run thing. I'm going to come back to this equation and see, does it work for this one? Can it work on this guy? Let me find a color I haven't used green on this one. So I'm going to go ahead and use my rise to run. Okay, and remember my rise is y and my run is x. So rising y, so it's running, it's rising 4 and 4, which is consistent, and it's a running 1 and 1. And so it's 4 over 1, so my slope is 4, which is what we already knew. Let's try it out on this one. Okay, again, I'm going to do rise over run. I'm going to just look for something consistent. Okay, so this one's kind of strange. Okay, I'm going to do this. I'm going to assume that I don't have this number here. So from 0 to 6, I can see that it rises 6. And from 0 to 2, I can see that it rises 2. Hey, wait a minute. 6 over 2 equals 3, which is our slope. Okay, I'm going to try it on this next one. Okay, I'm going to do one more. I'm going to go 6 to 9, okay? So from 6 to 9, which is my y, 6 to 9, it changes 3. And then 2 to 3, it changes 1. 3 over 1 equals 3. Okay, so I can use my ratio of rise to run even on a table. It's the change in y over change in x. Do I have another one? Woohoo, I got another one. So I'm going to look for my change in y over my change in x. That is some fantastic handwriting right there. Woohoo! Show that one to my grandma. Okay, so let's look at change in y. So it's going, I'm just going to pick one of them. So from here to here, it's negative 1. Okay, now I'm going to do my x. From here to here, it's 1. And that equals a negative 1, which is my slope. Maybe I pick a different one. Maybe I go from 7 to 6. It's my change in y. 7 to 6 is minus 1. From 2 to 3 is 1. And that gives me negative 1. Which is my slope. So I can do this each time. So sometimes your tables are nice because they're all in order. You can find your slope real quickly. Sometimes you got to do a little bit of calculating. You're looking for how much does it change in y versus how much it changes in x. All right, a couple things you just got to keep an eye on. A detail would be when y is changing, is it going down? If it's going down, then it's going to be negative, a negative slope. And if it is going up as it goes, like 069, it's a positive slope. 159, that's going up, it's a positive slope. 951, it's a negative, it's going down, so it is indeed a negative slope. All right, well, I hope that helps you out, kind of looking through this. Have fun trying to figure out these tables to equations situations. See you later, bye-bye. I'm going to go shove jelly beans in my ears and see if I can hear the sounds of yummy.